None. Hello and welcome back to Calculus 3, the last section of the chapter 13, change of variables in multiple integrals. You know what change of variables is, right? In Calculus 1 it was called U sub. Now this is going to be a U sub on steroids. All right, we are going to see how to change the variables in 3D. The issue here is that you don't just change one doesn't simply change the variables, right? We also have to worry about transforming the region on which you are integrating, and that could be a problem. So I will solve a very simple U sub problem from Calc 1 because there is the extremely important part for you to consider, and that is, let's say you have to integrate integral of x e to the x squared dx from 0 to 1. So what's happening here is we are going to say u equals x squared, du equals to 2x dx. We know we have to fix this 2, and then we also have to change the limits. So u1, when we plug 0, remains. Oh, these are bad limits, but they're gonna stay the same. I don't like that. You know what? Let's just go 0 to 4. I don't know. 0 to 4. So now I have 1/2, and the new limits are 1, and then u2 is you plug in 4 is 16. For e to the u du. So now it becomes 1/2 e to the u computed from 1 to 16, which is 1/2 e to the 16 minus e. Why did I put this 1? Should be 0. So it's just 1/2 e to the 16 minus 1. How many things did we change? Well, we changed the limits, and we also changed the variables. Now, what you need to understand is that when you have 0 to 4 on x-axis, we had 0 to 16 on u-axis. So there was a transformation there which changed these values. So interchanging limits, by changing limits in Calc 1 u sub will be equivalent to transforming the region in Calc 3 now. So 2D, and then for 3D also 3D. So we first have to learn about changing the region, and that is the only thing that I wanted to talk about tonight. So we have these transformations where we are transforming the region, and then tomorrow in class we're going to put all of this together into problems. So let's transform the region. First we have to have a transformation. Our transformation in Calc 1 was given here. So this was my transformation equation, where I plugged in x equals 0 to get u equals 0 and x equals 4 to get u equals 16. So that was my transformation. Now I'm going to have transformations given here. where the transformation is x equals some kind of function g of uv, and y equals some other function h of uv. So say that the transformation that it's given to me now is x equals cosine r cosine theta, and y equals r sine theta. So these would actually be my substitutions later on. We'll deal with that tomorrow. Today I just want to see what is the image of the transformation. So what do I get? So consider transformation from polar to rectangular coordinates given y, and then find the image under this transformation for the rectangle, over the rectangle. So what do I have? I have a rectangle which is pi over 2 and 1. And oops, sorry, that's the R and S input. R and theta. So that's the region S, and the region S of R and theta is given as R is stuck between 0 and 1, and theta is between 0 and pi over 2. So we see that's that rectangle. But now I want to use my transformations. So I'm going to use 4 colors here. I have the red one. Now for this particular region here, note that R is between 0 and 1. So if R is between 0 and 1 and theta is constantly 0, if I plug those in my x and y up there, note that x will be R, and then cosine of 0 is always 1, so x is just equal to R, which means that x will be between 0 and 1. And y is equal to R times sine of 0, which is 0, so y will always be 0. I actually have a first line that I need to draw for my transformation, and that line is this line here, from 0 to 1. Now this is xy. The next line that I want to work on would be the blue line here, and the blue line here has R always 1, and theta changes between 0 and pi over 2. Did I turn the stream on? Yes, good. So now when I'm working on the blue one, I have R is always 1, and theta is between 0 and pi over 2. Again, plug this in the transformation. X is equal to R is always 1, and theta changes. So I'll just put 1 times theta, because theta is going to be between 0 and pi over 2. Now y would be also 1 times, and then I have hold on. I wanted to say cosine of theta. That gives me the range. I'm supposed to write cosine here. There we go. So we know that in polar coordinates, when so we have now this, because when you look at this, you have traveled 0 to pi over 2, quarter of a circle, right? And the radius is 1. Any radius that I draw here, I'm going to erase all of these. Any radius that I draw is always 1. That's this piece. Then I'm going to have the green on top. And the green says that I have r from 0 to 1. And theta is always pi over 2. Plug in transformation. X equals, we have the r. And then now you have a cosine of pi over 2, which is r times 0, which is 0. So x is always 0. And y is r sine of pi over 2, which is always r. And r travels from 0 to 1. So I hope that you see that y is equal to r, so which tells me that the y goes from 0, between 0 and 1, and and that has to be this. And the last part is to talk about the purple one, which is the edge over here, where we see that r is always 0. If r is equal to 0 and theta is between 0 and pi over 2, well, x equals r cosine theta is going to be 0, and y equals r sine theta is also going to be 0. So what we get is just the point 0, 0, which is the point right there. And this is our region R. Now we transformed it. So I went from the rectangle into a quarter of a circle using the transformation for polar coordinates. This is the reason why in your in the polar coordinates double integrals they say over rectangular region, because in the eyes of the polar it is a rectangle, but if you transform it into x and y, it is a quarter of a circle. Now I see that some of you are confused, and that is probably rooted in the fact that you didn't think about these things enough yet. When you learn the polar coordinates for the first time, which is chapter 10 Calc 2, for some of you, what, 2 months ago, for the first time, you probably try to separate the two worlds and say, yeah, the circle is easy in polar coordinates because it's r equals 2, where in Cartesian is x squared plus y squared equals to 4. That all holds. But you have to understand that the circle in polar coordinates on a polar graph is a square, because the coordinate system is different and the space in it is different. So these two pictures are the same picture. Observe that the upper one is graphed on r theta graph, and the one on the bottom is graphed on XY graph. So far in your life, you always graphed exclusively on XY graph. You never graphed on the one on top. So the circle would just be a square if you graphed it there. You have to think about these things a little bit and look how they look like and so on. So we'll do another transformation. Maybe you should try and do one transformation, tonight or tomorrow morning. Just to try and get the feel for it. Try to find my older stream or find other stuff on YouTube of how the transformation is done. Each one of these integrals now will have the transformation, and that's the scarier part because you are not used to transforming regions. You're not used to that kind of thinking. So try to figure it out. We'll do one more transformation tomorrow, and then we'll jump into integrals, then we'll jump into review, and then that will be all. So I'll see you all tomorrow at some point. Bye, stream. Bye, Dan, right?
Bye, Dan.
Bye, Dow. Dow, yeah. Dow.